So OSHA Standard 29 CFR 1910.106, that is basically your ultimate survival guide for preventing workplace fires and explosions. Imagine you're performing a transfer of a liquid from a massive heavy drum into a smaller container. Doing that safely requires exact precision. But here's the thing. If you can't name the hazards or the equipment in English, you literally can't communicate the safety requirements to your crew. And communication, that's your first line of defense. Moving right along to Section 2, Important Safety Words, Building Your Vocabulary. Okay, for this part, I really want you to listen closely to how I pronounce these words and actually repeat them out loud. Let's kick it off with a pretty fundamental question to get us thinking. What makes a liquid evaporate easily? Why do some liquids just instantly vanish into the air the second you pop the cap, while others sit there totally fine, like a glass of water? Well, the answer is our first big technical term for the day, vapor pressure. Now, the official OSHA definition states that vapor pressure is the pressure exerted by a volatile liquid. It's a measure of a liquid's propensity to evaporate. But let's translate that into plain English, right? On the shop floor, it just means how easily a liquid turns from a liquid state into a gas or a vapor. That's it. Higher vapor pressure, it gives off vapors a lot more easily. All right, let's practice this one together. Vapor pressure. Say it out loud with me. Vapor pressure. Awesome. Let's do it one more time. Vapor pressure. Nailing this pronunciation ensures that when you're flagging a hazard to your supervisor, your message is heard loud and clear. No confusion. So, now that we've got evaporation and vapor sorted out, let's ask the next logical and honestly life-saving question. What actually makes a liquid catch fire? That brings us straight to flash point. OSHA defines flash point as the minimum temperature a liquid gives off enough vapor to form an ignitable mixture with air. The huge takeaway here, it's the vapor that burns, guys, not the liquid itself. The flash point is just telling us the exact temperature where that invisible, super dangerous vapor cloud starts to form. Let's get this word locked in right now. Flash point. Go ahead, repeat it out loud. Flash point. Spot on. Once more. Flash point. Out in the safety world, we have a very important saying. Low flash, high hazard. If a liquid's got a low flash point, it means it can generate dangerous, ignitable vapors at just regular, everyday room temperatures. That's scary stuff. Now, let's contrast two English words that might sound kind of interchangeable in normal conversation, but actually mean entirely different things under OSHA rules. Flammable versus combustible. The magic dividing line between the two, exactly 100 degrees Fahrenheit. If that flash point is below 100 degrees, bam, it's classified as a flammable liquid, also known as a Class I liquid. If it hits 100 degrees or higher, it's a combustible liquid, putting it in Class 2 or 3. They might sound the same to a civilian, but trust me, flammable liquids are way more volatile. Which brings us to Section 3, the flammable limits, lean versus rich. So we know vapors burn, right? But what actually happens when those vapors mix with the air around us? Well, there is a minimum concentration of vapor needed to ignite, and that's known as the lower flammable limit, or LFL. Below this boundary, a flame simply won't spread, even if there's a spark. Out on the floor, in popular industry jargon, we call this being too lean. It literally just means there isn't enough vapor mixed with the oxygen to catch fire or explode. Then, way over on the complete opposite side, we have the upper flammable limit, the UFL. This is the absolute maximum proportion of vapor in the air. Above this limit, a flame won't travel because the mix is too rich. There's way too much vapor and just not enough oxygen to burn. You absolutely need that Goldilocks zone right in the middle, the flammable range, for a fire to happen. These two short words are absolute staples in industry jargon. You'll hear them on job sites all the time. Lean and rich. Let's practice them together. Repeat after me. Lean. And now, rich. Perfect. Seriously, knowing these exact terms is a game changer when your safety team is out there doing atmospheric testing around a chemical spill. All right, moving into Section 4, Safe Storage Rules, Keeping Liquids Contained. We've deeply covered the invisible hazards of vapors, so let's talk about the physical world. Let's talk about the classic safety can. But listen, to be an officially OSHA-approved safety can, it cannot hold more than 5 gallons of liquid. Plus, it has to have 2 non-negotiable features, a spring-closing lid and a spout cover. These are meticulously engineered so that if the can gets caught in a fire, it'll safely vent the internal pressure instead of bursting and turning into a bomb. Let's practice the name of this container right now. Safety can. Say it with me out loud, safety can. Keep that iconic red jug visualized in your head. Let's do it one more time, safety can. Now, when you're dealing with larger quantities, you're gonna need a flammable storage cabinet. You should know these are heavily regulated. A single cabinet maxes out at 60 gallons of Class I or II liquids, and the engineering here is just amazing. They are designed to survive a standardized 10-minute fire test and structurally keep the internal heat below 325 degrees Fahrenheit the whole time, keeping those dangerous liquids fully protected. Okay, I need you to focus on this next vocabulary word because it is highly critical for building safety. Egress. Egress is simply a formal word for a safe exit or escape route. OSHA is incredibly strict about this. You cannot store flammable or combustible liquids, not even inventory for sale, anywhere that limits the use of stairways or the safe egress of your team. You can never, ever block an egress path with storage, period. Last but not least, Section 5, Inside Industrial Plants Safe Handling. How do we actually handle and move this stuff around inside an active working plant? When you need to transfer flammable liquids, OSHA only allows very specific safe methods. Let's go over these action words together. You can use a closed piping system. You can pour from those safety cans we just learned about. You can use a device drawing through the top, or you can transfer by gravity through an approved self-closing valve. These verbs, drawing, transferring, are your go-to English words to describe safe handling. Let's zoom in on that last method because it is a big deal. Gravity. Repeat it out loud. Transfer by gravity. Excellent. We hammer this home because OSHA explicitly bans using air pressure on a container to transfer liquids. Blasting compressed air into a tank can overpressurize it beyond what it can withstand, and worse, create a highly sensitive flammable atmosphere right inside the vessel. No way. We only use gravity or an approved pump system.